Okay, let's get started. Is this working? Okay. All right, so some announcements. Due to the canceled day yesterday, sadly the second year in a row, I delayed the deadline for the assignment by a day. So PS7 is due on Friday. We'll try to staff the lab. In fact, we will staff the lab with extra TAs on Friday. But I'd appreciate it if you all didn't wait until Friday to do it, since most of the TA help would be available before Friday. The thing you missed in the lab was going over the midterm solution, so I'm going to go over some of it here. You should go look at your graded midterm online, so that's easy to do. Just see right here this GradeScope link. If you click on GradeScope, you'll be able to see your scanned exam, and you'll be able to see the rubric we used to mark it. So you can see where points were taken off. If you have any questions, you can ask us. And if you think we made a mistake, which we sometimes do, you can submit a regrade request through GradeScope. And you have until next Tuesday to do that. When you do submit a regrade request or not, you submit it by the problem. So I had a few students who first wanted to ask questions about two different problems, and they wrote it up in one place. So each problem gets its own, really each box gets its own regrade request. Okay? Some of you, I have all the cheat sheets you used in the midterm in my bag right now. Some of them are true works of art. So if you'd like yours back, come see me. I'll give them back. Other than that, any questions or problems about anything before we go any further?
Should we do that during the break?
Yeah, during the break or after class, we get time to see me about the cheat sheet. Yeah?
Can you get a scanned copy of our business?
Get a scanned copy of what?
Of our business.
Yeah, the scanned copy will be in GradeScope. See this link right here, GradeScope? So like I can go into GradeScope, I can click on the midterm. You can see yours and yours only. Wish I hadn't done that now. Any other questions? Can't hear me anymore? Hello? Yeah, they told me before that this would go up and down. So I'm gonna try to increase the gain over here. Okay, is it working now? Okay, keep me apprised. Okay, so the midterm, I'm not going to go over it all because some of it you can just see for yourself. Like this first page here, the answers are there and there's really no explanation needed. You can just see what the right answer was. Problem 3, we talked about last time, so I'll skip that. So let's look at problem 4 here. Who could tell us what was the key to solving problem 4, to figuring out what types of values these methods take as parameters and return as results? Okay?
First of all, assuming that it's not going to throw an exception the way that you have it written.
Mm-hmm. Yeah, assuming it's not going to throw an exception. So for example, how do you know that H takes a double as a parameter? Yeah?
Looking inside the parentheses.
Yeah, you see a double sitting right here. So H must be expecting a double. How do you know that G takes a string as a parameter? Yeah?
It says that it's string.
Right, so G gets its input from whatever H returns, and it says right here that H returns a string. Okay? And then what type of value does G return? Well, G returns a a graphics because f expects a graphics. And then finally, f returns a scanner because that's, we're taking the return value and storing it there. So it's just a matter of understanding how methods compose that way. Okay? People had a fair amount of trouble with this. So a loop that processes every value in a collection. So first of all, if I stop right there, which of the three types of loops that we study process every value before it returns? Look at every value. So with optimization, accumulation, and searching, for which is that true? It's true for optimization. It's also true for accumulation. They don't return until the loop finishes. On the other hand, searching returns as soon as it finds what it's looking for, which could be in the middle of the loop. So it doesn't necessarily, searching doesn't necessarily look at everything. Okay, optimization, in addition, produces a value that's in the collection. It's looking for the best thing in the collection. So that's going to be an element in the collection. On the other hand, the accumulation loop produces a value that isn't necessarily in the collection. Maybe adding them all up or appending them all together. So you get something back that's different from anything that was in the collection. And finally, the searching loop processes some, not necessarily all, and produces a value from the collection. It's searching for something with a property. Okay, any questions about that? Okay. Here's a method F, and you can see what the answer is. It reports whether the list contains duplicates. And you might look at that and not get that idea at all, because it's comparing sizes of things. So how is it that this reports whether the list contains duplicates? So you've got an array list of strings here. And this method is going to return true if there are no duplicates in the list. It's going to return false otherwise. So who could talk us through this? Okay?
So when you initialize a set from that list, it's just going to remove all the duplicates for you.
Okay, so let me stop you there so I can say it, everybody can hear. So we're constructing a new tree set here, and we're passing the list to the constructor. And what that does is take everything from the list and put it into the new set. And if there are any duplicates in the list, they'll be removed when that happens. Then what happens next?
So then if your sizes don't match anymore, that means that some of the elements were removed, and so there must have been duplicates.
Okay, so after that, after the duplicates have been removed to create the tree set, if the size of the tree set is different from the size of the array list, that means that some duplicates were removed by the tree set constructor. And so the list must have duplicates in it. Okay, so you have to put several things together to answer that. Okay? Here's one that caused a lot of grief. What does that notation right there mean? Int ... Yeah?
It's an array of all of the ints that are passed into this parameter, but it could be any number of ints.
Okay, so what he said was, this notation is used to say that you can pass any number of ints to G. You can pass 0 ints, 1 int, 2 int, any number that you want. What happens is they're all collected together into an array, which is stored into this parameter nums. So basically, you can write this method treating nums as an array. That array contains all the parameters that were passed. So when we sort them and then return the last element, then we're returning the largest from that array, which is to say the largest of all these parameters. Yeah?
What's the benefit of doing that when we're just putting an array of?
Okay, so she asked, what's the benefit of doing this over just passing in an array of integers? It can just be shorter. You don't have to, like suppose you had a max method that could take any number of parameters instead of just 2. If you want the max of 3 things, you just call max on those 3 things. You wouldn't have to stop and build an array and then pass it in. You basically get Java to build the array for you. Yeah?
Would another advantage be that nums can be an array of any size? It doesn't have to be a fixed size?
Yeah, right. So yeah, nums can be an array of any size. And again, Java is basically figuring out how big the array needs to be for you. So sometimes it's convenient to do that way. Okay? So here's this method, and you're supposed to find the statement that best describes the behavior of H. And a lot of people said it throws an index out of bounds exception. I guess because we're catching an index out of bounds exception right there. So in fact, what happens is you write this loop, the loop runs forever. It starts the index at 0. It eventually is going to go past the end of the string, and an index out of bounds exceptions will be thrown. So given that an index out of bounds exception will be thrown, why is it not right to say that that's the behavior of H? Yeah? Right? Because we catch that exception right here and return the index. So if you call H, you're not going to see an exception. That's all internal details. We don't see the exception. What you see is a number coming back. And that number happens to be the length of the array, length of the string. So why is it the length of the string? Okay?
Because the index exception is no longer true with one after.
Okay? So this index gets bigger by 1 each time. The first time it is too big. Well, the last time it's not too big, it'll be the length of the string minus 1. And so then the next time the length of the string, the value of index will be the length of s. That's what triggers the exception. And it just happens that we're returning the length. Okay? So the correct answer was D. And finally, there's this one here. I was wrong last time when I said that the object versus class question had the lowest percentage. I think this one had the lowest percentage. I think it was 50%. So the question is, what does method 1 return when it was called? Well, int n is 5, return n. Why is this method call right here completely irrelevant to answering the question? Yes?
Doesn't assign anything, just method.
Okay, you're just calling a method. This statement does not change. This statement right here, this one, this method 2 call, it's not assigning to n. The only way the value of n is going to change is if someone assigns to it. And that's not happening here. And this method here cannot access n. Right? When it says n gets n times 2, it's changing that n. It's not changing this n. Local variables to a method are local to that method. They cannot be accessed from anywhere else. Yeah?
Would the answer to this question have changed if n was declared as a static variable?
Well, yeah, if n were a static variable declared outside of method 1, and the parameter here wasn't called n, we could arrange for it to do something different. That's quite a different question, though. Local variables are really local. Even though n is passed, and the parameter here is called n, these are two different n's. Right? This n is declared right here. And this n is declared here and used in here. So this stores 10 into the parameter, but then that goes away, and this n is unaffected. Yeah?
Does it go away just because method 2 isn't assigned to anything?
Well, it goes away because when you call a method, after it returns, its stack frame is popped off the stack. So basically the memory where it's stored its variables is reclaimed. That's true for any method. The memory that's used to store the parameters and the local variables exists only as long as the method is running. And when the method returns, you don't need that memory anymore. Okay, any other questions? Okay, the remaining questions on here are programming problems, so you can see the solution and compare it to yours. So I'm not going to go over those. But if you have questions, nonetheless, be happy to help you out. In my office, TAs can answer your questions and so forth. Okay, now let's return to what we've been talking about for this is the fourth lecture. We've talked about implementing classes. And to remind you where we were, we had implemented a version something sort of like hash map or tree map. We called it my map. We simplified things so that the keys are strings and the values are strings. And this was our representation. We have an array, a list of keys, and a parallel array list of values. So the two are the same length, and the keys array contains the keys, and no duplicates because it's a map. And the keys and values are stored at corresponding locations. So if the key is at index I of keys, the corresponding value will be the index I of values. And so the implementation was pretty straightforward. Let's glance at it. So this is map 1. There's our representation that we had. To create an empty map, we just create 2 empty lists, no keys, no values. To add, it depends. If the key is already known, if the key is in the list already, then we find out where that key is and replace the corresponding value down in the values array. Otherwise, we just add a key and a value to the end of the 2 lists. So that's what it takes to put an element into the map. Now, let's review. How many parameters does this method take? 2 is tempting to say, but it takes 3 parameters. What is the third parameter to put? It's an 8-word answer. It'll be on the file. Yeah? The object on which the method was invoked. Put was called on some object, some map, some my map object, and it's an implicit parameter. And in fact, it's called this. So when I say keys, I really mean the keys variable in this object. And I could go through and make it more explicit that everywhere we're talking about values and keys, it's really this dot values and this dot keys we're talking about. So just never forget that there is, to a non-static method, there's always an implicit parameter, which is the object in which the method was invoked. So that's the put method. To remove, we've got to look up the key. Well, that was commented out. We have to look up the key and find out where it is, and if it actually exists, we remove the key at that index, we remove the value of that index. We're just playing along with our design. To get an element, you get its index, you get the index of the key. If the key doesn't exist, we return null, because that's what the spec says to do. Otherwise, we return the corresponding value. And finally, to get the size, we return keys.size. So we could return values.size because they're the same length. We've made sure they're the same length. Okay, so that's what we did last time. Any questions about that? Well, I'm wondering how fast it is. So what I'm going to do is I'm going to have my map time mapped. Okay, it's right there. Go back and save this. So let's look what map timer does. What it does is it builds 50,000 strings to add to the maps. So it just goes through and creates 50, the string 1, the string 2, the string 3, actually the string 0, the string 1, the string 2, and so on. So it computes those strings in advance so we don't have to do it inside our timing loop. And then I'm just going to write a loop right here that puts the same key as the key and the value into the map. And so it'll build a map of length 50,000. And we time how long that takes. We repeat for tree map, do the same thing for tree map, and we do the same thing for a hash map. So first we time the hash map, the tree map, and the my map. So how do you think this will turn out? My map uses an array list underneath. And we know that array lists are more efficient than other ways of doing things. Do you think it'll be a big win for the built-in data structures, or will it be a close contest? What do you think? No? Let's see. I'll run it. So it's going to do my map first. So it's working on it. Okay. So my map took 8.5 seconds. Tree map took, if you round it, 0.04, and hash map took 0.01. Okay? So that tells you a couple things. One is that my map isn't a very good implementation. And we didn't even get that. We just did the add. We didn't test how long it took to look up things or anything like that. So either tree map or hash map blow my map out of the water. On the other hand, it also tells you that tree map is slower than hash map, which I've been telling you. But it's, you know, it's a factor of 2 or 3, not a factor of whatever that is. 100, 150 or something. Okay? So tree maps internally don't use lists, they use binary search trees. And hash maps use hash tables. And that's something you learn about in 2420. But there's something to this stuff, right? That's one reason you study that is to understand how a change in representation can make a huge change in performance. So choosing the correct representation is vitally important. Okay. So let's go back and look at the representation we used. Parallel arrays. Here we are. Can you think of a way of doing it that wouldn't involve 2 arrays? Maybe that would speed things up. How could we get by with just 1 array? Yeah.
Have one array and then get rid of the values, the keys, and the values.
Okay. So we suggested having 1 array, and we'll store the keys at the even numbered locations. And the value, the corresponding value, will be right after it at the odd numbered location. So the first key value pair will be at 0, 1, the next one at 1, 2. That would give us 1 array. One problem with that approach is it doesn't generalize to situations where the key and the value are of different types. So what do I mean by that? What if the key was a string and the value was a graphics object? Yeah?
Could you possibly have it automatically, like a regular array goes 0 to whatever there are, or could you have that be the value to the key?
I didn't follow that.
So in an array, it has values at certain points, you can call this, you can call that value.
Right.
Instead of doing a separate array to have it call keys versus values, you could just have it change what is an integer first into
Okay. So I think what you're suggesting is something like. First, let me just back up. What if the key was an integer? And the value was a string. And furthermore, what if the keys happened to be, you knew the keys would go from 0 to 1,000? What would be a fast way to represent a my map with only a single array if you knew the keys were integers that went from 0 to 1,000? Yeah? You just use an array of length 1,001. And, you know, and now the keys are indexes to where the value is stored. And in fact, that's a lot like a hash table. The way a hash table works is you take the key and you run what's called a hash function and convert that key into an int. And then look up into the array. And that's an oversimplified explanation. You know, you have to deal with things like 2 keys that get turned into the same int. But I've told you the basics of a hash table. Okay? But what's the problem with having the keys and the values in the same array if you want to have different types of values than keys?
Well, an array can only have one type, so could you make an array that has the type object? Just put
Okay.
everything you want into it?
Okay? So I'll tell you what he said in combination with other things. The problem is an array everything in an array has to be the same type. So if you had keys were strings and values were graphics objects, how would you declare the array? You couldn't declare an array of strings because then you couldn't store graphics in it. You couldn't make an array of, or a list of graphics objects because then you couldn't put the keys in it. And he was pointing out, there's actually a type called object. And every reference type is a kind of object. But that's a story for a different day. Turns out there's a hierarchy of types, and there's something called inheritance. And we'll talk about that in a few weeks, but for right now, we won't go there. So what would be a way to get by with one array, even when the keys and the values are of different types? Yeah?
Could you make your own object that stores private member variables and then just have an array of that object?
Okay. We could have an array of pairs. Okay? And then a pair object would contain a key and a value. Maybe that would make our implementation faster. So let's see what that looks like here. I'll just get past my map. So let's make an array list of pairs where the key value pairs, each pair in the list contains a key and a value. Right? And then no two pairs have the same key. That's the uniqueness constraint. So that way you only need one array, but it's an array of pairs. Now, where are the pairs going to come from? Do you suppose there's a pair class built into Java that stores two strings? I don't believe there is, so we can just build it ourselves. We build a helper class, the same way you build helper methods. Okay? So it'll look something like this. Internally, kbps stands for key value pairs. You might have a list of two pairs, AX and BY. So what are the keys? Let's say sort of making you guess. I'll just tell you, the keys come before the values. So A and B are the keys, X and Y are the values. And so abstractly, if you view this as a map, it's not much difference. It's a map with two elements. That list of pairs turns into that map. So nothing groundbreaking going on here. That's illegal. Why? Right, I've got two pairs with the same key. That's not allowed. Okay, let's see what we can do about implementing this. So that is map 2 package. Okay, so I declared an array list of pairs. Well, let's go see what a pair is. There it is. So it's just code that I wrote with separate packets. You can see that over here it's pair.java. It has two instance variables, which I call key and value. It has a constructor that takes a key and a value in and initializes the instance variables appropriately. So you say create a pair containing this key and this value. They're stored into the pair. If I ask you to give me the key, I just return the key. If you're asked to get the value out of a pair, you return it. And if you're asked to change the value of a pair, you just change it that way. So very straightforward code. One thing I want to point out, why did I use the keyword this? Was I trying to just show you that this is the implicit parameter one more time? Yeah?
Because you have a key as a parameter that's passed, so you need to specify they're using this key.
Okay. So key is a parameter, and it's also the instance variable. So if I did this, if I just said key gets key, what am I doing? I'm taking the value of the parameter and storing it into the parameter, so this does nothing. It's an easy mistake to make, but it's not as easy as it used to be because Java underlined it in yellow and it says the assignment to variable key has no effect. So that's not one you want to ignore. Now, you might ask, why did I give the parameters the same name as the instance variables? Why do you suppose? Why was I more creative and give them different names? What do you think?
To illustrate a point, and because key is just, there are too many logical names for it.
Okay, so yes, you gave two great answers. One is to illustrate a point, so I could explain this. The other is, I don't know what else to call it but key. I could call it key X or something, but that seems stupid. So a lot of times when I can only think of one name for something, I end up using parameters in the constructor that have the same name as instance variables. So then I have to do that this stop business. Yeah? No hope of hearing that. Much louder. No, so if I changed, so he's saying if I called it something else, if I said key X here, key X, I wouldn't need the this anymore. There's no confusion between them. Yeah, the problem occurs when the parameter or a local variable and the instance variable have the same name. Okay? So anyway, now we have a pair class to use. So we go back to the second version of MyMap. What's it going to take to create an empty MyMap? Remember, the instance variable is called kbps, so what value should we give kbps? Right, we just create a new list, an empty list. Okay, that's easy. What would it take to put something into a key? Now, put something into the map. So we're given a key and a value to add. What do we have to do? Yeah?
If you want to add a pair object, you want to set that pair object key value variable.
Right, so if the key is not already in there, well, no. Yeah, a couple ways to do it. Assuming the key isn't already in the map, we have to create a new pair object and stick it on the end of the list, right? Okay? So we'd do something like this in that case. We would say pair P equals new pair key val, and we would say key value pairs dot add P. And that works as long as that key is currently unknown. But what if the key is already in there? What if the key is already known to this map? What do we have to do? Suppose it's stored at index. Suppose we have an index variable. Well, let's put it this way. Well, just someone tell me, what do we have to do if it's already in there? There's some pair that contains key. Yeah?
Update it.
We have to find that pair and update it. Or replace it would be another alternative. You have to find that pair and replace its value. Or equivalently, we could create a new pair and just write it over the old pair. So I kind of like the write over the old pair. So suppose we knew the index. Suppose there was some way of finding the key. Suppose we had a method called findKey that would tell us the index in the array, of the index in the list of the pair that contains key. How would we finish our method here? And let's assume it returns -1 if there is no pair that contains the key. So what do we do if we get -1 back? Meaning there was no pair that contained the key. Got an idea?
Maybe throw an exception.
No. Not that. Yeah?
Do what we've already written.
Right. That's when we do this stuff. We discover that the key is unknown, so okay. Let's create a new pair and add it to the end. Otherwise, we know that the pair at that index contains the key, so let's replace it with a new one. So how do we do that? How do we put a new pair in there? What pair do we need to store? Yeah?
We want to use the key value, like out the key value pair list. We want to get the pair that matches the index.
Okay. So what he's saying is we could go into the key value pair list, pull out the pair that contains the key and change its value. I want to do it a different way, just for the heck of it. I just want to replace the pair that's at that index with a new pair. So that sounds like I need to do kbps dot set index. And what's the new pair I need to put there? Basically this thing, right? Okay, let's put that there. Now, why is that not working?
Because P is not in scope.
P isn't in scope, so one way to fix it, I need this pair in either case. So I'll take that out. And voila. So what we do is we find out where, if there is a pair that contains the key, we find out where it is. If there wasn't such a pair, we add a new pair to the end. If there was such a pair, we replace that pair with a new pair. Either way, we got our list fixed up. All we need is this find key method. Okay. What about removing a key? How would you remove a key from the map implemented this way? Yeah?
You do find key and then you remove the element that has index.
Okay. So we'll use that helper again. We'll say, okay, tell me what index it's at. And as long as index is greater than or equal to 0, we'll just go key value pairs dot. We'll remove the thing at that index. We'll take that pair out. Great. What do we do to return the value to which a key maps? Someone gives us a key, we have to find the corresponding value. What do we do? Yeah?
Basically the same thing, but return it instead of
Yeah.
updating it.
Pretty much the same thing. You find out where the thing is, and if it exists, we return kbps dot get of index, and otherwise, and what I do wrong? Why is this thing right here underlined in red? Yeah.
That returns an object.
Right, this is a pair, right? There's a pair stored at the index. We need to get the value out and return it, so we'll say get value. And if the pair was not, if no pair with that key was found, we return null. And how to return the number of elements in the map? Yeah.
Do like the last index plus 1 or something?
Well, last index plus 1 is the answer, but you know we can get the size easily enough just by returning the size. Okay, so that leaves us with an implementation. Problem is we're missing find key. So where do we even put find key? Does it belong in another class somewhere? Yeah?
Should it be in the same class, maybe as a helper method?
Okay. Should it be in the same class as a helper method? What's the argument for it being in the same class? What does it need to access to do its job? Yeah? Yeah, it has to be able to access the instance variables, so it better be in the same class, and it better not be static. Because if it's static, it won't be able to get at the instance variables. So let's go here, ask it to create the method for us, and there it created it for us.
Wait, how did you just do that?
I'll show you again. I hover the mouse, It's suggested, it says the method's undefined and it offers to create it for us. How can you resist?
Wow.
Is that a CDM thing, or is that just?
No, this is just straight Eclipse. And so it creates it and did a pretty good job. It called the parameter key. Figured that out from context. It figures out what it's supposed to return from context. It made it private. You can change that if you wish. It just basically gives you stuff. And sometimes it won't get it quite right. It'll, you might have to modify that slightly. But at least gets you started. Okay, so now there are no errors in the program, but you know we still got to implement find key. So let's take a break and we'll do that. Okay, let's get started again. Is this working?
Nope.
Does this work? Okay, so we just need to write find key and we're done with this class. So we need a comment up here, Java doc, and we'll say returns a pair from kbps that contains key. returns the index of a pair from kbps that contains key or negative 1. Meaning there wasn't one. Now look at that and tell me why this had better be a private method. Why would it be a mistake to make this a public method? And I want you to imagine that you're using IntelliSense and you see that there's this class called MyMap with a method called findKey. Yes?
The person using your class without like adding methods to it or something like that shouldn't even know how it's operating.
Okay. So basically, the specification mentions kbps. That will mean absolutely nothing to a client, right? They don't care what the private instance variable is called. So this is a private method. It's just for our use. Okay? Now, this is going to be a just a straightforward searching loop. So we'll just say for every pair in kbps, if p.getKey equals key. Okay. And now I'm stuck. What's my problem? Why is the for each loop not going to fly this right now? The problem is I need the index. And this loop doesn't tell me the index. So I'll try again. I'll use just a regular for loop. And if kbps.getI.getKey equals key, I'll return I because I found it. And if the loop terminates, I'll return negative 1. Okay? I think I did that right. So I'm just looking through, looking at each pair in turn, getting the key out, and see if it's the one we're looking for. If so, I return the index. Otherwise, I return negative 1. Okay. So let's see if it works. So here's my map test. Let's see if I've made a mistake. Why is it I so rarely make a mistake? Why do I always pass the test the first time?
Because you're a teacher.
Am I just scary good programmer?
Yes.
Years and years of experience.
Well,
No, the true answer is you saw me make mistakes, right? The thing is, if you did your program in front of a big class, you'd find out about your mistakes right away too. I make mistakes all the time, and when I'm doing it by myself in my office, I don't pass the test the first time. But when I have students to tell me what I've done wrong before I've even realized it myself, it makes it a lot easier. So, plus I have years and years of experience. So I won't downplay that. Okay, now do you think we've improved? Here's map timer again. This time it'll test this map. You think it's faster than the old one? There's only one array. Does that make it twice as fast? Half as many arrays? So the other one took 8.5 seconds. Yeah, Ruby?
Where the heck do you get map timer?
I wrote a map timer I wrote myself before class. Well, let's see if we've improved things by decreasing. The thing is, we've decreased the number of arrays, but of lists, but the lists are bigger because they contain pairs now instead of strings. Let's see if it makes any difference. So the old one took 8.5 seconds roughly. These timings aren't exact. I've never timed this one, so I don't know what to expect. So it's slower, it turns out. So adding those pairs required a little bit more method. If you actually look at the code, you'll see it's a little bulkier because we have to not just find something in a list, we have to pull out the key or the value from it. Okay, so we went backwards, yeah?
Can you explain why that's slower, or is that outside this scope?
It just does more. What the reason it's slower, let me make sure I'm in the right place. You know, not only do we have to get an element out of the array, but then we have to call this method to get the key out. Actually, I'd have a hard time explaining why it's slower. I sort of have a vague sense, but I'm not trusting my explanation right now. Yeah?
Is there a way to mathematically determine like how much more efficient something is?
Okay, so that's a good question. Is there a way to mathematically determine how much more efficient something is? What you'll learn in 2420 is that you can look at an algorithm and you can group algorithms into equivalence classes. You can say, this algorithm is a linear algorithm, or this algorithm is a quadratic algorithm. And what you're saying then is that linear algorithms, if you double the size of the input, the running time doubles. Whereas a quadratic algorithm, if you double the size of the input, the running time quadruples. But if you take two, that's sort of the limit. If you take two algorithms that are both linear, there's really no easy mathematical way to say which is faster. You just essentially have to run it and see. Now, before we leave this example, I want to go right here. I told you that when you call a non-static method, and find key is non-static, you have to supply an object for it to operate on, right? I don't see an object before find key. So, what's going on? Yeah?
Is it the implicit parameter?
It's the implicit parameter, yes. So the deal is, just like, think about static methods. If you call a static method from inside the class where it's defined, you don't have to put the class name before the static method. The class name is implicit. Similarly, if we're calling another method on the same object that put was called on, so put was called on an object, find key is called on the same object. So really, this is the same as saying this dot find key. You're calling find key on the object on which put was advanced.
What do you mean it was put on an object?
What's that?
What do you mean it was put on an object?
When put is called, like up here, is there a put? Yeah. So when we called put, we said invoke put on this map M. So anytime put is called, there's a this. There's an object in which the method was invoked. So when you call a helper method, you're calling it on the same object. And it's implicit, so we don't have to put it there. Now, what would be wrong? What if we declared, where'd that thing go? What if we declared, here it is. What if we declared this static? What would happen if you declare this static? You get an error because this is an instance variable. You cannot access an instance variable from a static method because there's no object on which the method was invoked. Now, if you hover the mouse on it, you'll see it offers to change kbps to static. And so you go, sweet. Okay? And all the errors went away. But now, if I run the tests, if the tests are halfway decent, I even pass all the tests. Okay? What's the problem with calling this thing static? Yeah?
You can't change its value ever.
Well, you can change its value.
Wait a second.
Yeah?
Every instance of my map is going to use the same kbps.
Right. It's static. There's one per class. So every object that we create, every, what are these called? Every MyMap object we create is going to be accessing the same array, or the same array list. So that'll, you know, so if you, that's just not going to fly. Basically, there's only one possible list. Now, why did I pass all the tests? None of my test cases uses more than one object. Okay? But if I change it here, if I say, let me go up to test 1 here. I say map M, let's say M1 equals new map. And then we're going to create M2, which is another map. And with that thing declared static, both of these objects are using the same array list, because there's only one to go around. And then I'm going to do something like M2 dot put. A, B. And then I'm going to assert that M1 size is 0 and M2 size is 1. And then I'm going to assert that if we do M1.get on, let's say, X, we'll get null back. Okay, so it ought to pass those tests. We create two maps. One of them we add a key to. So the original map is size 0. The new map is size 1 because we put something in it. And if we look up something on the original map, we'll get back null. But it's not going to pass. Where's it going to fail? Let's run it and see. Okay? It failed on this assertion right there. So why did it fail that assertion? Yeah? Yeah, M1 and M2 are, you know, they're sharing the same list. They're really the same object. That's why you don't declare instance variable static. You declare instance variable static, it's no longer an instance variable, it's a class variable shared by all the objects. Not what you want. But unfortunately, students get into trouble. Remember where this started? We mistakenly declared this thing, static when it shouldn't be because it has to access instance variables. And then we accepted the only suggestion, which is to change kbps to static. And that's bad. It should have suggested make this not static. And then it works right. Yeah?
Where did you declare the instance variable in this class?
The instance variable is right up, right here.
And does that have to be initialized before it's ever called?
Yeah, it has to, yeah, the instance variable has to be initialized before it's used. And you typically initialize it. If you choose to, you can initialize it right here. Or you can initialize it from inside the constructor. The constructor needs to initialize it.
So there has doesn't have to, there's nothing in there that should be PS.
Not what you're saying there's nothing in there. What do you mean by nothing in there?
Well, I guess this is kind of confusing because I don't know. It looks like there's supposed to be more information inside the block. But that's just how the instance.
This is just the declaration of the variable. And here's where we actually give it a value. We store an empty list in it. Yeah?
Are instance variables always considered declared before the main method box, even if they're below the main method in terms of?
Yeah, well, yeah, so he's asking about at what point are they actually declared and created. I mean, with an instance variable, it doesn't exist until you create an object. As soon as you create an object, it'll contain this instance variable, and the constructor will initialize it. Now, once I declare it static, now there's just one of them. And it's created as soon as the class is loaded. Yeah?
What I mean is that if you move that declaration below the my map method, would
Yeah.
it be incorrect?
Right, I could move that, I could mix it up. I could put the private variables at the bottom. I'm just in the habit of putting them at the top. People see them first.
That's conventional.
Yeah, that's pretty conventional. Yeah.
And why do we make it private again? What's the...
Okay, good question. Why do we make it private? Yeah?
If somebody's, it's public, somebody can probably edit it.
Okay. If it's public, then anyone that uses our class can go in and start modifying it. And we had to be very careful to make sure that it was used properly by our methods. We don't want to give the whole world license to go and start storing things in this instance variable.
Are you going to show how to use that and keep it static?
No, I'm not going to show how to use that and keep it static. We don't. There's the other reason, so I've told you two reasons why we make instance variable private. One is so you can change your mind in the future. You do it this way and you say, this is too slow. I'm going to replace implementation with something else. As long as the representation was something else, as long as variable is private, no one is depending on it. If you make it public, anyone that's using your class may depend on that instance variable. So you can't change it. And the other is you do not want the outside world to be mucking around with your carefully curated instance variables. Okay, now, on to my favorite class. Rat. Okay, so Java provides ints, doubles, but it doesn't provide fractions, right? You can't do arithmetic with fractions in Java, exact arithmetic. You can approximate it with doubles, but maybe you'd like to get exact answers. And so the idea is we can provide a rat class, rat short for rational, that provides fraction objects. And we'll be able to create some rational numbers with constructors. We'll be able to add, subtract, multiply, divide, compare, convert to a string, convert to a double. We'll be able to do those operations on rational numbers. And to show you what I mean, here's a little program. I've got a method called extension 1 that computes 1/2 plus 1/4 plus 1/6 all the way up to 1 over 2 times n. So if n is 4, it would do 1/2 plus 1/4 plus 1/6 plus 1/8. That turns out that series diverges. Here's another one called extension 2 that just does the same thing, but the loop runs backwards. So it starts with the smaller number and adds the bigger numbers. And it's using, this is all double arithmetic here. So it's using doubles to add it up. And finally, extension 3 does it with rats. So it does, it creates a 0, that's the 0 rat right there, and then it does rational arithmetic, which looks different because I can't redefine what plus means, so we're having to use methods like add. And I'm going to run this. Right now I've got the caller extension 3 commented out. And what do you notice? We printed out extension, I think it was 36 was the value of n. We get the value computed by adding the numbers in one direction. We also get the values returned by adding the numbers in the opposite direction. It's the same numbers, same number of additions, and yet you get different answers. Why is that? Why do we get different answers when you're doing the same number of additions of the same doubles? It's not much different, admittedly, but it's a little bit different. Yeah? Yeah, it's just, anytime you do arithmetic with doubles, you can get a little bit of round off error. And the more operations you do, the more it can accumulate. And the error that you get is going to depend on the exact numbers you're adding. And so therefore the order can matter. And that can become catastrophic if you add, if you do enough arithmetic. Gradually, that runoff error can corrupt every digit in your answer. So you got to be careful when you use floating point numbers. And in fact, we teach courses, entire courses on scientific computing and the like, where you learn how to deal with this kind of stuff. CS 3200 is Introduction to Scientific Programming. So that just shows you, if we did it with fractions, we get an exact answer out. Numerator, denominator. All we have to do to make that come true is to implement this. So, we need a representation. How can we represent a rational number? What instance variables do we need? Yeah?
Will work, we just have 2 ints, one for numerator and one for denominator.
Okay, so he suggested 2 ints, a numerator and denominator. Makes sense. That's what a fraction is. But I'm going to use longs instead of because you know that ints, if you get up to about 2 billion, they overflow and they sort of wrap around and become negative. Longs are just twice as long as ints, so it takes longer for them to make that change. And our fractions kind of screw up when the ints get too big. So I'm going to use longs. Any two? If you cut open a rat object, are there any combinations of numerator and denominator that you would expect not to see? Yeah?
Can the denominator never be 0?
The denominator better never be 0. So I'm going to say this is the denominator of the rat. We know the denominator is not equal to 0. Any other restrictions? Get your suggestion, yeah.
Neither can be the square root of a negative number.
Neither can be the square root of a negative number. Well, yeah.
Although integers can be.
Yeah, that's you're thinking more about real numbers, I think, than fractions. Yeah?
If the numerator is 0, if num is 0, then the rat is 0.
Okay. So if the numerator is 0 and the denominator is 1, that's 0, right? So maybe I should put it this way. Represents the fraction numerator divided by denominator. In fact, trying to put these in separate comments is problematic, so I'm going to put everything right here above both of them. So I want denominator to not be 0. Now, is 0 over 2 the same as 0 over 3? Is that the same fraction? 0, right? 1 over 2 is the same as 3 over 6, right? Same fraction. So are you comfortable with having, say it comes time to print out a rational number, and the numerator is 3 and the denominator is 6. Do we want to print out 3/6? Probably want to print out 1/2. What if the numerator is 2 and the denominator is -3? Should we print out 2's divided by -3? You're used to seeing -2 divided by 3, right? So it turns out that our task will be easier if we make sure, first of all, that it's always the case the denominator is not just not equal to 0. We want the denominator to always be greater than 0. We'll only let the numerator be negative. And we want the greatest common divisor of the denominator and the absolute value of the numerator to be 1. And I don't want them to have any factors in common. I don't want to store 3/6. I want to store 1/2. And there's another advantage to keeping the common factors out. It means that it prevents our numerator and denominator from getting too big and overflowing as fast. Okay? So let's work with that. So here's a constructor. I'm going to skip down here. This is supposed to create the rational number n over d. So can we just do this? Numerator is n, denominator is d. Okay? What's wrong with that? Someone says, here's a 2, here's a 5. Make the fraction 2/5. In that case, it does the right thing. Yeah?
It doesn't necessarily follow your rule that.
Right. It doesn't necessarily follow our rule up here, that we do not want to have it. So what if we get 3 and -5? What we want to store is -3 and 5. So let's fix this up so that when we construct a rat, it follows our representation strategy. So first of all, if d is 0, it says to throw a illegal argument exception. So I'll do that, take care of that right away. Okay, how can we make sure that our denominator is not negative? Yeah?
There's no other statement to if t is less than 0, multiply by -1 and multiply by the numerator by -1.
Okay, so if d happens to be negative, we're going to say d equals negative d. D gets negative d, n gets negative n. So we're putting the negative sign, reversing the sense of the numerator to keep the denominator positive. Okay, how can we make sure that d and n don't have any factors in common? Yeah.
You do mod, see if the mod comes out the.
Well, it's not, yeah, he's suggesting you do a mod. That's actually not, we don't want to do a mod. Yeah.
Is there a function that gives you the greatest common divisor?
Okay, he's asking, is there a function that gives you the greatest common divisor?
Like math?
No, actually in this file. So it'll compute the GCD as long as B is positive and A is not negative. So I've got a static method there to compute the GCD. So really what I do here is I say, okay, we compute the GCD of the denominator and the absolute value of the numerator. And finally, we can give the initial values to numerator and denominator, to num and denominator, num and den. I can say this is equal to n divided by g, and this is equal to d divided by g. So what I'm doing is I'm just dividing out the greatest common divisor. So if numerator is 3 and denominator is 6, we'll divide a 3 out of both of them, and we'll get 1 and 2. So that's what puts things in lowest terms. So all this code is designed to store all the numerator and denominator in a standard form, a unique form. Now, why do we go to all that trouble? Why do we make the constructor so complex? Why do we impose these constraints on ourselves? Yeah?
Aren't those just part of the specifications of the program?
Well, it's not part of it. This stuff is I made up while I was standing here. I could have just said, okay, as long as the denominator is not 0, anything goes. Why did I also say that the denominator had to be positive and the GCD had to be 1? Yeah?
Make it easier to understand.
Well, to make it easier to understand, certainly, but also it makes the other methods easier to write. For example, okay, so now we construct a rat and make sure everything's in lowest terms. What's it going to take to convert it to a string down here? Because we already know that the denominator is not negative, there are no factors in common. Yeah, what do we do? So here's some examples of what we want to do. So if the numerator is 3, the denominator is 4, we want to produce 3/4. If it's 6 divided by 8, we want to put out 3/4. If it's 2 divided by 1, we want to put out 2. If it's 0 divided by 8, we want to put out 0, and so on. So what's my two-string method need to look like? Yeah?
You would need to return the numerator and then the slashes, or plus the slashes of string, plus the plus.
So fundamentally, that's what we need to do. We don't have to worry that the denominator will have a negative sign because we made sure that that can't happen in the constructor. But this isn't quite right. This would print out, if say the numerator is 0 and the denominator is 1, it would print out 0/1. We don't want that, so we need to make a special case. If the denominator is 1, what should we return? Just the numerator converted to a string. And what if actually, let's do this first. What if the numerator is 0? What should we return? Just plain old 0. Else, if the denominator is 1, we just return the plain old numerator. Else, we're going to return numerator/denominator. Now, what if we hadn't been careful in the constructor to put everything in lowest terms and to make sure the denominator was positive and removing the greatest common divisor? What would, yeah?
We'd have to do all those checks, but in each method that deals with the numerator and denominator.
Yeah, we'd have to do that elsewhere. For example, we'd have to do it in two-string. But since we took care of the constructor now, we don't have to worry about it. We know that when we're called, things are in lowest terms already. We just have to deal with a couple of edge cases. Now, I want to finish, we'll finish some of this next time before we move on to a different topic. But I want to point something out here. Notice, what do you notice about this that you've never seen in a class that I've written for you? What are these three things you're looking at? Yeah?
Overloaded constructors?
Oh, he said overloaded constructor. Sure. You can have more than one constructor. Yeah?
An entire class to write.
Well, it's an entire, that's not new though. So what's...
Instead of writing them to the base.
Yeah, so what's new here is there's multiple constructors. So this constructor here, if you call the rat constructor with no parameters, you're supposed to create the rational number 0. So what should we do here? How should we initialize the numerator and denominator? Yeah? Yeah. Numerator is 0, denominator is 1. That's lowest terms. Okay? What about down here? This constructor, if you just give it a single long, you're creating a rational number n. So what should I do? What's the numerator? And what's the denominator? 1. And that'll work. But I just want to show you a different alternative. You can also do this. Okay? Now you're going to look at that and think, man, this again. This is called passing the buck. This particular construction, when it appears as the very first line of code in a constructor, what it means is call another constructor that takes 2 parameters and let it worry about this. So essentially, you're passing the buck to this constructor. In a sense, you're calling this constructor and telling it, initialize a rat whose numerator is n, denominator is 1. And then it deals with it. So how can I do that same trick up here? That's 0. Or I could actually do this. So what would happen when you call this constructor? It would see this and say, I'm supposed to run this constructor. And it would see that and say, I'm supposed to run that constructor. So we pass the buck all the way down to here, and then that one does its thing. Yeah?
So does each instance of the constructor rat, does it not need to have a different name or a different...
No, each instance of the constructor has to be called rat, because that's what constructors have to be called. What they have to have, though, are they have to take either different numbers of parameters or different types.
So you can't do another one that looks exactly like that?
No, I could not create another 0 argument constructor here. So I just show you this because you'll see it. It's just sort of another use of the keyword this that's completely separate from the other use. And it's just a way of, basically, I can create helper constructors just like I create helper methods. I could even have, if I chose, I could make this thing private. You can have private helper constructors if you want to. Yeah?
Is it good practice to pass the buck to a series of constructors or only one constructor?
Well, he's asking, is it good practice to pass the buck through a series? Not necessarily. I'd be tempted to do that. But since there are all these intricate things going on in here, I like the fact that this program, all the constructors depend on this thing to do the right thing. I don't have to worry about lowest terms up in these. It's a matter of taste. I just want you to see it at least once from me before you see it somewhere else. All right, we'll stop there, and one of the things we do next time is to look some more at this.